Hello, chemistry students. We are going to do a little lesson on something called significant figures. And we haven't talked about this yet, so this might be a little foreign. I don't know that you would have talked about this in ninth grade, so this is probably the first time you're hearing this. So in this next section, you are going to learn to determine the correct number of decimal places to carry. And we're talking about when you're expressing an answer, like that's a question I hear a lot from you is how many decimal places should I keep in my answer? This is going to clear that up. And then the biggest part of significant figures is determining how we count those zeros. Like if 0 is one of the digits, does that count as one of our places or not count? So this probably doesn't seem very clear right now, but it will as we go forward. Hopefully you have your books at home. And on page 67 in your books, there's a awesome little chart. I actually made copies of this for you because I don't expect you to memorize these rules. And I'm going to put it on this handy dandy green paper. But there's a series of rules. So as we go through this lesson, I would like you to have your book open and refer to these rules. So there's a little table that has kind of this is copied right from the book, has this cool little dude in a striped shirt. Actually, I have no idea if it's a dude or not, but let's look at this because otherwise you're going to watch this video, it's not going to make any sense. So pause the video for just a moment, grab your textbook. I'm sure you're reading it every day because you want to keep really, caught up on your chemistry lesson. So go grab that. And then I'm just going to dive right into things. So you're going to use this chart to determine the number of significant figures. So when we talk about significant figures, this is a measurement that includes all the digits that are known plus a digit which is estimated. Remember I said we talked, I'll show you my handy dandy drawings when we talked the other day about, if you have a measuring device like this where only every 10 milliliters is marked, I can estimate one digit beyond the 10, which would be the ones place. So I could estimate, like if I had water right here, to that level, I might say, that looks to be about 15. So I know if I write this, that this last digit, which is the 5, is my estimated digit. I didn't actually read that, but that's my best guess on the level of liquid in this graduated cylinder, which is, not marked to every milliliter. And this one I said I can estimate to, because even though we only have numbers every 10, but every single little milliliter line is actually marked, so I can estimate to the 10th place or 10th of a milliliter. So that's where that's coming from. And then this, so this ties in with that. We are going to determine for just right now how many significant figures are in each of these numbers. So we're going to use these rules. So A, 1.257. If I look on here for a rule that seems to be similar to this, the one thing I noticed right away, because we're going to talk a lot about zeros, okay? We're going to talk a lot about zeros. This one doesn't have any zeros. And that's important because then when I start looking, I think the only one that really talks about numbers that don't contain zeros is rule number 1. So 1.257, it looks like the rule says, rule number 1 says every non-zero digit in a reported measurement is assumed to be significant. So since none of these are zeros, I'm going to assume that this is 4, and I'm just going to say SF. I say sig figs a lot because significant figures just gets really long. And I even am going to write down this is rule number 1. Okay, okay? For significant figures, this is rule number 1. Let's look at B, 2.00. So I'm looking for something that has a non-zero digit before the decimal and then zeros after the decimal. So let's pause this while you find the rule, please. So I see rule number 4 says zeros at the end of a number and to the right of a decimal are always significant. And here's why. So this is, it's saying these zeros are significant. So this is 3 significant figures. We're going to say rule number 4. Here's why this is significant. If I measure something that is, let's say, I measured and it's exactly 2 meters long, what this, putting 0.00 here infers that I had a device that was actually accurate to 2 point, and then 2 decimal places beyond that. So I was measuring in meters, it was accurate to the, 0.00 meters or a hundredth of a meter. But I measured it and it actually was exactly 2 meters. There wasn't any more or any less than that. But I want to know that, I want to state very clearly that I'm not rounding here. I actually had a super precise measuring device, but it ended up being exactly 2 meters. That's important. That's why I wouldn't just write 2 and not include the 0.00, because if I put 0.00, it's like, oh yeah, I used a really incredibly precise measuring device. It just happened to be right at 2. All right, let's look at C, 1.250. Pause this for a moment while you find this on your sheet. So 1.250 looks the most like number 4 again. So we're talking about, it ends with zeros after the decimal. So remember, all non-zero digits always count as significant figures. And then we're always talking about, should we count the 0 or do we not count the 0? This is the exact same rule. So this is 4 significant figures. I think my choice of colors is not the best. I should have went red and green. Red and green for Christmas. I should have done that. And then again, it's rule number 4. For the same reason. Why would I put this extra 0 on the end if it wasn't really important in expressing this number? D, I think when we look at D, the number 2000, there's no decimals in here. This is probably the one that students argue with me the most about. And just know that I didn't make these rules, and it's okay if they're a little confusing or if you don't understand the importance right now. So if I have the number 2000, there's no decimal here. Written this way, we would assume that let's say that I weighed something and it was 2,000 pounds. I probably don't have a super precise measuring device, scale or whatever, to give me a number that's much closer than that. So this is gonna, so if you pause this for a moment and look at the rules, this is actually rule number 5. This is 1 significant figure. The reason this is 1 significant figure is because I probably, again, just don't have a very precise measuring device. Otherwise, I probably would have got a lot closer than to the nearest thousands, right? So, and again, we said this is rule 5. All right, let's look at E, the number 205. Pause that for a moment. Find an example on your handy dandy sheet, or sorry, in your book. You don't have the sheet yet, so on page 67 in your book. This looks the most like number 2, which has zeros in the middle of non-zero digits. So, and the rule says for number 2, zeros appearing between non-zero digits are significant. So this is 3. Three significant figures. Rule number 2. All right, let's look at F.005. This is very different than B and C, where the zeros are after the decimal and at the end of the number. These are in front of. We consider these to be placeholders. So let's look on our paper, pause for just a moment, pause the video if you need to, find the rule. F looks like rule number 3, where we have zeros in front of non-zero digits, even though we have a decimal. The zeros are considered placeholders and they don't count. So this is, it says leftmost zeros appearing in front of non-zero digits are not significant. They act as placeholders. By writing the measurements in scientific notation, you can eliminate such placeholders. So this is 1. One significant figure. This is rule number 3. And when they talked about, yeah, if you write this in scientific notation, it can easily become one significant figure. See, I just made it one significant figure. All right, and this G is a little bit tricky. I've put a decimal at the end. Usually we would put a decimal and then a 0, but I just want you to know when I put a decimal here that this suddenly means that I really did use a device that is this accurate. This would be 3 significant figures. And I think we would probably say rule number 4. So going forward, we will use these rules to guide us in, so how many places should our answer be when we add, subtract, multiply, or divide? And I'll go into that actually in my next video. I do want to caution you, so H, and this is a hard and fast rule, when we do dimensional analysis and we use conversion factors, we never let our conversion factors limit the number of significant figures in our answer. And it's very important because looking at these numbers separately, obviously 1 is one significant figure, 60 is also one significant figure, but this is 3 significant figures, so I want my answer to be 3 significant figures. I don't want it to be limited by my conversion factor, because conversion factors a lot of times have a 1 in them, so we just don't ever want that to be a part. So never ever let conversion factors limit your number of significant figures that you express your answer in. Hopefully that's clear. You have a worksheet to practice using these rules. Good luck.